temp M. So where are we? Here. Okay, temp M. Okay, this is the chart that I'm going to show you. Whoa! Look at that. My God, that is awesome. Okay, you tell me, why do you think that's awesome? Why is this exciting? Okay. While you are kind of pondering and going deep into thinking mode, notice things that are needed in a graph. Okay, I need the y-axis labeled, temperature M, it's in degrees centigrade. Doesn't seem to show the whole thing. I'm not sure why. Maybe I need to extend it. Can't seem to do that. But anyway, the y-axis should be labeled there. The x-axis should be labeled here, and there should be a title to the graph. All graphs have to have these things, otherwise it's meaningless. Okay? Anyway, back to the excitement. Why is this exciting to you? Anybody? Oh yeah, okay. So you think this is like a sine wave, also called a sinusoid. But is it truly just a sine wave? Let's go back to the training video where you'd actually seen that graph in the activity that we did. Okay, where is it now? Why is it opening there? I have no clue. There we go. Okay, so this is what you should have seen in the YouTube video. This is a sine wave. Okay, this is a pure sine wave. This on the other end's not quite that. Not quite that, but you know, kind of has got the same features. It's got this nice bottom here and then a top, and then it's kind of oscillating. You can see that. But in addition to that, you can see that there's a what I would call a ramp. It's like a line going across like that. Okay, if you want to picture this, it's like having a straight line, and on top of it there's a sine wave, and on top of it there's a sine wave. So essentially what I'm trying to tell you is that this data here, the black data, can be modeled with a straight line together with a sine wave on top of it. Now that is truly exciting. Okay, if you've played around with U84, and I'm not sure how many of you guys did this when you did pre-calc. I know when we did pre-calc, if those guys who are with me, when we did pre-calc, we did do some exercises of modeling on the TI-84. Okay, and we did some quadratic modeling. We put in some data, and we used the regression capabilities of the TI-84 to come up with that. Now let me just tell you, the TI-84 is not going to be able to come up with a model that fits the data that we see there. It's not a one-shot deal, unfortunately. So this is where we need to think and apply our skills of what we've really learned. Okay, so back to this modeling activity, and like I said, what I want to do is really fit this as a straight line, some line that's going to go like this, and on top of it a sine wave, on top of it a sine wave. Okay, so I need to come up with the equation of a line first. Okay, all right, so hopefully everybody's with me on this. So the first line that you can kind of picture is a line that joins this point here, the bottom point here, the bottom point here to the bottom point here, and then the top point there and the top point there. Okay, so you've got two lines there. Now what we're going to do is we're going to get the equations of these two lines. So remember, the equation of a line is y equals mx plus c. So we're going to get two m's and two c's, and we'll just kind of roughly average the two and get a line that's kind of in between the two. Okay, kind of common sense kind of thing. Okay, all right, how do we get the equations of the two lines? Okay, so what you're going to do is you're going to take your cursor, okay, and point it roughly at what you think is the bottom part of the curve there. And when you leave the cursor there, it'll read out two values to you, and in my case it's 1980, 7.65262. So 1980 is the time or the x-axis, 7.65262 is the y-axis of the temperature. Okay, so take those two numbers and record them, and going to open a new sheet, and we're going to call it WS. So open a new sheet and we're going to call it WS, and you'll see that I've already, like I've mentioned to you before, I've already recorded these things. Okay, I've already recorded these things, so you see everything there. In your case, you're going to be filling in individual items. So the first two things here that you see, bottom 1x and bottom 1y, really pertains to us having looked at the let me go back to this temperature and looked at this point here and picked out its x and y coordinates. Okay, picked out its x and y coordinates. Okay, don't have to be completely precise. You don't have to get exactly the numbers that I do. Remember, a lot of this is kind of experimentation. I mean, you know, when you run experiments, not all people are going to have the same results in an experiment. So what I've got is my first pair is 240, 7.65262. Okay, that's the pair that I got. Then go ahead and extract the oops, my bad. Go ahead and take a look at the graph and find the coordinates of this data point, okay, the second bottom data point. So if I go back to my WS and please again label that to worksheet as WS. I think by default Excel comes up with sheet 1, 2, 3 and so on. Okay, so label that as WS and enter the next pair out here. Okay, so here's the other pair. So what you've got is you've got 2 points in a line. Okay, right, this is going back to algebra 0 now. Okay, you guys know 2 points make a line. You guys know how to find the slope. You know how to find the intercept. Okay, I'll let you go ahead and do that on your own. Okay, I'm not going to walk you through this algebra 0 stuff. All right, then what you're going to do is going to do the same thing but for the upper part of the line. So that'd be this peak here, okay, and this peak here. Okay, so again, get the two xy coordinates for each one of them. So get the xy coordinates there, get the xy coordinates there, and then record them in the next two sets. Okay, so top 1x, 1y, top 2x, top 2y. Okay, and I've gone ahead and done the calculations, at least in my case, for slope 1, intercept 1, slope 2, intercept 2. Okay, go ahead and do that. Okay, go ahead and do that. I'll give you a couple of minutes to finish that off. So again, one more time, what you've got is you've got the slope and intercept for the line that will correspond to the line that joins this point at the bottom and this point at the bottom, and then you'll get the slope and intercept of a line that joins this point at the top and this point at the top. Okay, so you should get two slopes, slope 1, slope 2, and two intercepts, intercept 1, intercept 2. Like I mentioned to you earlier, I'm gonna do what, you know, real engineering kind of stuff that happens. Okay, you take averages. Okay, you take an average. So I'm going to take the average of slope 1 and slope 2, and you can see the formula right there. Okay, so the average is computed as equals the word average, comma, go ahead, select this cell, comma, and then select the this cell here. Okay, and that'll make you the average. That gives you the average. Okay, you can see that average of J2 comma L2. Remember, J2 means the cell in column J, row 2. Okay, so you got average slope and you've got average intercept. All right, one more time. Okay, the equation of a line